I have already discussed, or I have already made a video about the circular disc method and the circular ring or the washer method. So in this video, I'm going to discuss the third method on how to determine the volume of a solid of revolution. This method is the cylindrical shell method. Suppose you have this area, this region, and you want to revolve this region about the line x equal to 3. Now, and this time, in order to get a cylindrical shell method, the rectangular strip must be parallel to the axis of revolution. In the previous method, like for example, for circular disc method, the strip must be perpendicular to the axis of revolution. At the same time, one end of the strip must touch the axis of revolution. The second method, the circular ring method, is that the rectangular strip must be parallel also. Perpendicular, perpendicular to the axis of revolution. But uh, the two endpoints do not touch the axis of revolution. Okay. This one, the cylindrical shell method, the rectangular strip is parallel to the axis of revolution like this one. So if you want to revolve this area, this is what will happen. So this rectangular strip, once it is revolved, this is the form, okay, with um, very small thickness dx. So how are you going to solve or determine the volume of this cylindrical shell? Okay, let's consider this one. This is a shell with a very, very small thickness. No? How do we get the volume of this? What you will do is you cut this shell, cut, and then stretch both sides, left and right, straighten, no? Like this one. Stretch left, and then uh, and this will happen. This is the result. So it's more of a plate with thickness dx. So the length of this, um, the length of the cylindrical shell, na it becomes rectangular parallelepiped is circumference of the circle. Okay, so this is circumference of the cylindrical shell, and this one is height, and then you have thickness. So it depends on the cylindrical shell. So thickness is either dx or dy. So the volume of this is similar to volume of rectangular parallelepiped, which is length times width times height. So your dv is height of your strip. So you have to determine this, the height of the strip, and then circumference, which depends on the radius, like this one, radius, and then thickness. So determine the height, and then circumference, and then thickness. So that's the volume of a differential element sa using cylindrical shell method. Uh, let's solve this one. Find the volume of the solid generated by revolving about the x-axis, the region bounded by the curve y equal to x cubed and the lines y equal to 0 and x equal to 2. This problem was solved already using the previous method. Let's check. Okay. So this was solved using the cylindrical disc method. Okay. So let's solve this again using cylindrical shell method. So this is the region and you want to revolve it about the x-axis. Now, since our axis of revolution is horizontal, our strip must be parallel also. Therefore, horizontal strip ang gamitan. Yeah. We will use the horizontal rectangular strip. Yeah. So for horizontal strip, our notation is XR and XL. No? So our X right is 2. O constant na siya. From lower limit to upper limit, 2 gini siya. Our X left is X lang. X. Okay, and then we have distance of Y. Okay. So, supposed to be, for this point, it should be YL and then Y right. Okay. From the origin, when you plot this point, that's X left, Y left. While for this point, it's X right, Y right. But since it's horizontal, Y is constant. So Y sub L and Y sub right is equal, no? Or we can just denote it by Y, simply Y. And then thickness of dy. So when you revolve this strip about the x-axis, this is the result. Yeah? So again, our differential volume is equal to height or length of strip. In this case, it's length of strip. No. But kung vertical sa height of strip, same lang. Length of strip times circumference of circle times thickness. Okay. So what's the length of our strip? Base figure, this is our strip, no? And it's equal to 2 minus XL or XR minus XL. This one. And then our radius is Y. Okay? Radius nato is Y. And then thickness of dy. I mean. So therefore, our differential volume is this. Length of strip times circumference times thickness. And then you integrate dy. So our limits, ang limits nato y from 0 to this point. We have determined this one already. But when x is 2, y is equal to 8. So we integrate it. We integrate the volume, dv. And since dy, we have to replace x sub L by y. And we'll make use of this equation. How do we get x? It's simple, no? X is cube root of y or y raised to 1/3. So we have this one. Our limits 0 to 8. So 2 pi y, 2 minus x is y raised to 1/3 or cube root of y. So next is you distribute y and then use the power rule. This is the result. And then you evaluate from lower to upper limit and then simplify. Okay, the answer is 128 over 7 pi. Let's check this value sa previous method or the other method. Okay. Using the cylindrical disc method, the answer is 128 over 7 pi. Next one. Compute the volume of the solid formed by revolving the region bounded by the curve y squared equal to x, y equals 2, and x equal to 0 about the y-axis. Again, this problem was solved using the previous method. Let's check. Using cylindrical disc method, okay, the answer is 32 over 5 pi. Revolve about the y-axis. Okay, so this is our region. Now this time, we'll use a vertical strip. Yeah. Since our axis of revolution is vertical, then our straight must be vertical also. And using our notation for a vertical strip, it's y up and y down. So our y up is 2. Our y down is simply y, no? Or y down. And okay. The distance of this strip from the y-axis is simply x. Again, when you plot this point, it's from the origin. You have x down, y down, okay. And then for this point, you have x up, y up. So x down and x up are equal, no? Or simply we could just denote it by x. And then thickness dx. So when you revolve this strip about the vertical axis, this is the result. And then label, no? Height of the strip is simply y up, this one, y up minus y down, radius of x, and then thickness of dx. So our differential volume is height of strip times circumference times dx. So dx, so our limits are values of x. So, from x equal to 0 to this one x. So what's the value of x? What's the coordinate of this point of intersection? When y equals 2 from this one, when y equals 2, x equals 4. So 4, 2 ang coordinate ani na point. So we integrate and we have this point of intersection 4, 2. Okay. When y equals 2, x is 4. Okay. So we replace y by x kay dx na lang. How do you solve for y? It's simply square root of x or x raised to 1/2. This one. And then after this, you distribute x and then use power rule. And then after that, evaluate from lower to upper limit. And then simplify. The answer is 32 over 5 times pi. Check the previous method. The answer is 32 over 5 pi. Another one. Find the volume of the solid generated by revolving the region bounded with the curves y squared equal to 4x and y equal to x about letter A, the x-axis, letter B, x equal to 4. Again, this problem was solved using one of the other two methods. Uh, Using the circular ring method. The answer is 32 over 3 times 5. So this is the bounded region, and since we are going to revolve the area, the region about the x-axis, horizontal ang axis of revolution. Therefore, our straight must be horizontal also in order to get a cylindrical shell. So, label Z, x right, x left, y distance, and dy. No? And then revolve. This is the result. Okay. The length of the strip is x right minus x left, and the radius is y. X right minus x left, and the thickness dy. Okay, length of strip, circumference, thickness. And then integrate ang limits na to, dy from 0 to this point. So, you have to determine or locate the point of intersection. So, you equate the two equations. But we have solved this one sa previous method. 4, 4. Okay. So, since dy we replace xr and xl in terms of y. So, our x right is line. So, x is simply equal to y. So, we'll just replace this one by y. And xl, x sub l is parabola, blue. How do you solve for x? It's y squared over 4. Y squared over 4. Like this one. And the next is you distribute y. And then integrate using power rule. And then evaluate from lower to upper limit. And then simplify. Let's check. The answer is 32 over 3 times pi. About the line x equal to 4. Okay. Same figures, other method. Since our axis of revolution is vertical, then our strip must be vertical also. Notation, we have y up, y down, distance x, take note, Our distance x or y, it should be referred sa coordinate axis. Kaya sa plotting, x down, y down, x up, y up. So, x down and x up, they are equal, or simply x. And we have dx. Now, this area, this region is to be revolved about this line, x equal to 4. Therefore, the radius will be this one. The distance of this strip to x equal to 4. That will be the radius. Oh, because x equal to 4 now becomes the center of our shell. Okay? So, x equal to 4. So, what's the radius? This distance. Okay, this one. It's simply 4 man, 4 minus x. And our height is y up minus y down. So this distance is 4 minus x. Okay. So be careful. No? It's not always x and y. Sa radius. Okay. X and y if the axis of revolution is either x-axis or y-axis. But if the area is revolved about a different horizontal line or different vertical line other than the coordinate axis, then you have to be careful with your radius. It's not x and y. You have to analyze carefully. Again, this is 4 minus x, this one. And thickness dx. So volume is height, circumference, 2 pi times radius times thickness. You integrate 4, I have nyo, 4. So limits is from 0 to 4. Now, since dx, we'll replace y up and y down by x. So our up is blue, parabola. What's the value of y? That's the square root of 4x. Y down is line, so it's simply x. We have this one, pointed with the section 4, 4. Oh, okay. Y up is this one, square root of 4x, or simply 2 square root or 2 times x raised to 1 half, or 2 square root of x. Minus y down line, so y is just equal to x. And then you expand, you distribute, you have this 2 times 2x raised to 1 half times 4, you have 8, 2 times this, negative x times 4, negative 4x, 2, 2x raised to 1 half times x. The exponents are added, 1 half plus 1, you have 3 halves. Negative x times negative x plus x squared. And then integrate using the power rule. And then evaluate from lower to upper limits. And then simplify. The answer is 64 over 5 times 5. Check. 64 over 5 times 5. Using the circular disc ring. Circular ring method. But this time we're using the cylindrical shell. And then this problem also, find the volume of the solid generated by revolving about the y-axis, the region bounded by the curve y equal to x cubed, and the lines y equal to 0 and x equal to 2. About the y-axis, so from our previous method, zero about the y, but then we used the circular ring. This time, um, we'll use the we'll use the cylindrical shell method. So this is the region, and let's revolve this region about the y-axis. So since vertical ang axis of revolution, therefore our strip must be vertical also. So x, y lang. Y up minus y down. Our down is 0. So y lang. Pag revolve, y, and then our radius is x, the thickness of dx. So our differential volume is height, circumference times thickness. And dx man ta sa limits na to 0 to 2 lang. And then we replace y by x from the equation y is x cubed. So 2 pi, let's write the constant before the integral, 2 pi. And then y equal to x cubed times x. X cubed times x raised to 4. The integral of x raised to 4 is x raised to 5 over 5 from 0 to 2. So you evaluate and then simplify. The answer is 64 over 5 times 5. Same lang. Then revolve about the y. Is 64 over 5 times 5. So to recap or to review, in order to get a cylindrical shell, the strip must be parallel to the axis of revolution. And always remember that the differential volume is similar to the volume of a rectangular parallelepiped, length times width times height. Like this one, height sa strip, circumference times thickness. Or kung horizontal, length of strip times circumference times thickness. So I hope that you have learned something from this lecture. Thank you for watching.